Hey everyone, I decided to make a video recording of tomorrow's class instead of actually giving class because this practice test is long and I'm not sure I'd be able to finish it properly if I were to give two individual classes, but instead I can just make a longer video going through these problems and post them on YouTube. So that's what I'm going to do. Please try to do these problems yourself first, just to see if you're able to. And then look at this recording to if you have any questions. And if you have other questions, email me and we can go over specific problems individually. Okay, so let's begin. So the first couple of questions they ask us, first, to find the limit if it exists, or show the limit if it does not exist. The first one is the limit as x, y go to 0, 0. So 1 second, it's recording. Okay, lim as x, y go to 0, 0 of x and y cubed, x times y cubed over x squared plus y to the 6, x squared plus y to the 6. So in these type of questions, you're generally going to, first, in this situation, we should notice that if x is equal to 0, or if y is equal to 0, then this top part is going to be equal to 0, and so the whole thing should be equal to 0. So if the limit exists, it would be 0. And that would basically mean that we are approaching 0, 0. One of them would be y is equal to 0, so we would be approaching from this direction. And the second one would be x is equal to 0, so we are approaching like that. So in such a case, we would have limit as 0y goes to 0, 0 of x, y to the third over x squared plus y to the 6 would be equal to the limit. And honestly, we can just put up here 0, here 0, and then here 0, just to see what we're doing. Limit as x 0 go to 0, 0 of x times 0 over x squared, and this of course would be 0. So if the limit exists, it will be 0. But we can take the function, so for x we can take x is equal to y cubed. That is another way in which we can be approaching 0. It would look something like, let me see, maybe something like this. All right, and that's how we would be approaching 0, 0. And in this circumstance, we will have the limit as y cubed, y go to 0, 0. And now instead of x, we're going to have y to the 6th power over y to the 6th power plus y to the 6th power, which is going to be y to the 6th power over 2y to the 6th power, which is going to be 1/2. And because these two don't equal, they don't equal, we know that the limit does not exist. So that would be the answer for the first problem. Okay, for the second problem, Yeah, so let's try once again. Okay, so the question is find the limit, if it exists, of xy going to 0, 0, xy times y squared minus 3xy plus 2x squared, 3xy plus 2x squared over x to the fourth plus y to the fourth, x to the fourth plus y to the fourth. Okay, so now again, if we are approaching x and y, so if we're approaching either from this direction or from this direction, meaning x is equal to 0 or y is equal to 0, then this limit, the limit as, so for the first one we would get 0, sorry, 0, y goes to 0, 0 of this thing, whatever, I'm just going to put that dot dot, is equal to the limit as x0 goes to 0, 0, which would be equal to 0 because that either this would be 0 or this would be 0, and so the entire first part would be 0. Now what would happen if we approach along the line x is equal to y? Now in such a case, we would get the limit as, let's say x go to 0, 0 of x squared times x squared minus 3x squared again plus 2x squared over x, so 2x to the fourth power. Okay, good. So what would end up happening here is, let's see, so this part over here would be minus 3x squared plus 2x squared, which would be negative 1x squared. Okay, so this would be x squared times x squared minus x squared over 2x to the fourth. And this should once again be equal to 0. Okay, so the limit of this thing would once again be equal to 0. So let's see, let's try to see if there's a different way of approaching this, which would get us some different number. Okay, so I had to pause the recording briefly to try to think about how to solve this problem. It's actually not that complicated. We just need to realize that we don't want this top part. Wait, 1 second. Yeah, you don't want this part to cancel. So the way to do it is by taking, let's say y to be equal to x over 2. And then, give me actually 1 second to look at something. Okay, so y is equal to x over 2. So now if we try to do the same exact thing, we are going to get the limit as x comma x over 2 goes to 0, 0 of x squared, well, let's just do x times x over 2, no, yeah, x times x over 2, so that would be x squared over 2 times, and then we would have x squared over 4 minus 3 over 2 x squared plus 2x squared over x to the 4 plus 1 over 2 to the 4th x to the 4th. Okay, and then we're taking this limit. So some of these constants we can put together. So let's see what that would be. So that would be from in here, we would have, so this would be equal to the limit. I'm going to ignore the limit for now. So let's just write it would be equal, but we have to remember that there's a limit being done over here. So we would have x squared over 2 times 1 over 4 minus 3 over 2 plus 2 times x squared over 1 plus 1 over 2 to the 4th times x to the 4th. Now this stuff cancels, so we would get 1/2 times 1 over 4 minus 3 over 2 plus 2 over 1 plus 1/2 to the 4th, to the 4th. Okay, and that would be the answer, and this would not be equal to 0. And so because in one direction we get 0 and in the other we don't, the limit once again does not exist. So that's the answer to the second problem. Let's continue. So the third problem, actually we can just plug in 0, 0 everywhere, and then we get 2 over 3. This is continuous, so the limit exists. And same thing with the fourth problem, 3 and 5 being plugged in here will not give us any problems. So once again, in such a case, the limit will exist. And we can find it by just plugging in the points by the rules of continuity. So let's move on to the next problem. So for the following 3 parts, consider the function, okay, find the rate of change at the point 4, 0 going towards the point 5, 1. So let's start with that. So now f of x comma y is going to be equal to 4 square root of x e to the xy minus 25 sine y Okay. And so first we want to find the rate of change from the point 40 to 50. So 5, 1. Okay, so we know that the directional derivative in the direction u of f at a point P is going to be equal to the gradient of f at point P dotted with u, provided that u is the unit vector. So we need to find the gradient of this, plug in the points 4, 0, and then we need to find the unit vector that goes from here to there. So find the vector, take its magnitude, that will give us the unit vector. Then use this formula and we will solve that problem. So let's start by finding the gradient of f. So the gradient of f at x comma y is equal to, so for the first part we have the product rule. So this would be f with respect to x, f with respect to y, which is going to be equal to 4 1 over 2 square root of x e to the xy plus 4 square root of x e to the xy times y. Yeah. Okay, and then for the second part, we will have 4 square root of x times x e to the x y times x minus 25 cosine of y. Okay, so the gradient at the point, so the gradient of f at the point P is going to be, and P is at point 4, 0. So that is going to be 4 times 1 over 4 e to the 0, which is 1, plus 4 times 2, and now y is 0, so this whole thing is going to be 0. Okay, that's the first coordinate. So the first coordinate is going to be 1, and the second coordinate is going to be, let's see, okay, so it's going to be 4 times 2 times 1 times 4, and then y is 0, so minus 25. Okay, which is going to be 1 comma, and then we are going to have 8 times 4, which is 32, minus 25, which is 7. So this is going to be our gradient f at point P. Okay. Okay. So now we need to find the unit vector from 4, 0 to 5, 1. So first, in order to find the vector, so let's start with the vector b, and that's going to be equal to 5 minus 4, comma, 1 minus 0, which is equal to 1, 1. And so the unit vector u is going to be 1 over the square root of 2, comma 1 over the square root of 2. Okay, so now we can say that the directional derivative in the direction of u of f, point P, is going to be 1 comma 7 dotted with 1 over the square root of 2, comma 1 over the square root of 2, which is going to be 1 over the square root of 2 plus 7 over b squared of 2, which is going to be 8 over b square root of 2. So that's the answer for the first part. At the point 4, 0, in what direction is the value of f not changing? That is, for what unit vector u is this thing equal to 0? So we would like, we know that the gradient is orthogonal to our level curves, whatever they may be. And in order to find the vector that's not changing, we want to find the vector that's orthogonal to them, something like that, so that we remain on the level curves. Now our gradient is 1, 7. So we would want a vector such that if we dot with 1, 7, we are going to get 0. So if we choose the vector, let's call it w, is equal to -7 and 1, then we would have -7, comma 1, dotted with 1, comma 7. That would be equal to -7 plus 7. And so the directional derivative in that direction would be 0, because these two are orthogonal. And we can even check that. So the directional derivative in the direction of w, but we would need w to be, in the direction of, oh, 1 second. Yeah, okay, I'm not going to try that. But anyway, this is the point. The point is, like I said, w is going to be orthogonal to our u's. Our u's are normal to the level curves, and so the directional derivative in the direction of w is going to be 0. Okay. Let's see what's next. Find the direction of rate of maximum decrease effect at 0.04. So the direction of maximum decrease is the negative of the gradient, and our gradient is 1, 7, so the negative is going to be -1, 7. So, which is equal to -1, -7, and that would be the direction of maximum decrease. Okay, let's move on to the next problem. So for the next problem, they say let that equal that. Okay, find the partial of w with respect to t. And actually, I think that this exam comes from 230, class 230, and for that we would use the chain rule, and we are going to learn about the chain rule. So I don't think a problem like this will show up, but just in case it does, we can solve it using what we know by plugging in our x, our y, and our z into x, y, and z, and then taking the partial of w with respect to t, the way we know how to do. So let's do that. So w is equal to x cubed y plus z over x, where x is equal to cosine rst. And again, I don't really think that this will show up in the exam. I think this is just coming from a different class, plus e to the s squared t. Okay, y is equal to r squared st, and z is equal to t ln s. So w we can write W in terms of, this is X, cosine RST plus E S squared T cubed times R squared ST plus T ln of S over cosine of RST plus ES squared T. Just plugging everything in. And they ask us to find the partial of W with respect to T. Okay, so that's going to be equal to 3 cosine RST plus ES squared T squared times negative sine RST times RS plus ES squared T times S squared, okay, times all of this times R squared ST. That was this part of the product rule, with the chain rules, plus, and now we're just going to copy the first part, cosine RST plus ES squared T cubed and R squared S. Okay, then. So now we finish this part. Okay, now the second part, we need a quotient rule, but again some chain rules. So let's continue. Plus cosine RST plus S squared T times ln of S minus T ln of S times negative sine, so let's turn this into positive, sine RST and RS plus second, okay, so then okay, let me keep this as minus, and then I have a minus over here, and so plus ES squared T times S squared, and okay, all of this over the bottom part squared, cosine RST plus ES squared T squared. So this would be the answer. It's not too straightforward, but it's just product rules and chain rules and remembering what's constant and what's not. We will learn a easier way to do this, but now if this appears on the test, this is how you would do it, plugging in X and Y and Z and taking the partial derivative. Okay, let's see what's next. Oh, and then plug in pi, 3 and 0. I'm not going to do that right now. Okay, so now fourth question. They say that the blender was gas. We have pressure and volume and temperature satisfied. So let's write that down. P is equal to P plus 1 over V squared v minus 1. Okay. So they want us to provide the linear approximation for t near the point with t equal 1 and v equal 2. So our point is t equal 1, v equal 2. Okay, so we know that the formula for our linear approximation is going to be t is going to be approximately t0, so t at this point. So let me actually write t in terms of pressure and volume. So now we're going to have t at 1, 2, plus the partial of t with respect to p at 1, 2 times p minus 1 plus the partial of t with respect to v at 1, 2 times v minus 2. So this would be our linear approximation. And so now we just need to figure out what this stuff is. So let's start by taking the partials. So partial of t with respect to p is going to be equal to, so let's just take the derivative. Well, we can just take the derivative of this and keep this the same. So that would be 1 plus 1 over v squared, v minus 1. Okay. And so then t, partial of t with respect to p at the point 1, 2 is going to be equal to 1 plus 1 over 4 and times what? Yeah, so let's say 5 over 4. Okay. Now t with respect to v at 1, 2. Okay, let's just do t. Partial of t with respect to v is going to be equal to p plus okay, we're going to take derivative of this times that. So let me get it complete for a second. So v squared times derivative is so 0, and then this times derivative of v squared, so negative 2v over v the fourth, and so then these v's cancel, and we get negative 2 over v cubed. So now t, partial t at 0.12 is going to be negative 2 over 8, which is going to be negative 1 over 4. Okay. Finally, t at the 0.12 is going to be equal to 1 plus 1 plus 1 plus 1 over 4 times 1. So it's 1 plus 1 over 4, which is going to be 5 over 4. Okay. So now the linear approximation of t, so t is can be approximated linearly by 5 over 4 plus 5 over 4 times p minus 1 minus minus 1 over 4 times b minus 2. B minus 2. Okay, so this would be our linear approximation. Okay. So next they ask, use your answer to estimate the temperature when t is equal to 1.1 and v is equal to 1.95. So that would mean that t at that point would be approximately 5 over 4, but it was at the original point, plus 5 over 4 times, and we would have 0.1 minus 1 over 4 times, and then minus 0.05, so plus, plus 0.05. So this would be the answer. Okay, let's go on to the next problem. Consider the function that, use the linear approximation to estimate the value of that. Okay, so let's first build a linear approximation around the point 0, 1. So f of x comma y is equal to e2 x over y squared plus 1. And we're going to try to build a linear approximation around the point 0, 1, so that we can approximate what this is at the point 0.01, 0.9, and 0.1. Yeah. So once again, we would have that f at the point 0, 1. Oh, sorry, at the point 0.01 and 0.9 is approximately f at 0, 1 plus the partial of f in the x direction times x minus 0 plus the partial of f in the y direction times y minus 1. Well, this would be for x and y, but then we would plug these ones. So right now, this is x, and this is y. So let's start with that. So what is f? Oh, sorry, 0, 1. Oh, fine. I'm going to rewrite this and as well. Start the way it should be. So that would be x, y is equal to f at 0, 1. Okay, so what is f? Partial of f with respect to x is going to be e2x times 2 over y squared plus 1. Partial of f with respect to y is going to be negative e2x times 2y over y squared plus 1 squared. So partial of f at with respect to x at the point 0, 1 is going to be 2 over 2, which is 1. Partial of f with respect to y at the point 0, 1 is going to be 0. No, 1 second. No, not 0. It's going to be negative, and then we are going to have 1 times 2, so negative 2 over, then at the bottom we're going to have 1 plus 1 squared, that's 2 squared, so 4. This is going to be negative 1/2. Okay, so then f at xy is going to be equal to f, so let's f at 0, 1, that is going to be 1 over 2. So 1/2 plus 1 times x minus 0, so x, plus, so then minus 1/2 times y minus 1. So f at the point 0.01, 0.9 is going to be equal approximately, this is approximately 1/2 plus 0.01 minus 1/2 times that would be 0.1. Let's see something. Yeah. So 0.9 minus 1, so that would be 0.1, but negative, so this would be plus, and this would be 0.1. And that should be the solution to that problem. Okay, let's move on to the next problem, and I'm going to put another screen. Okay. So, for the following 2 points, consider that function. At the point P is equal to 0, 1, 2, find the maximum rate of change in the direction of maximum rate of change. Find the rate of change of f at the point P towards the point Q. Okay, so let's do that. F of x, y, z is equal to yz plus e to the xyz, e to the xyz. So let's start with, at the point P is 0, 1, 2. Right, so P is equal to that. Find the maximum rate of change, the direction of maximum rate of change. So that would just be the gradient and the magnitude of the gradient. So the gradient of f is equal partial with respect to x, partial with respect to y, partial with respect to z, which is going to be, okay, so partial with respect to x is going to be e x y z times yz. Partial with respect to y is going to be z plus e x y z times xz. Partial with respect to z is going to be y plus e to the x y z times xy. Okay, and so then the gradient of f at a point gradient of f at that point P is going to be 2, comma, and then for the second part, we need 2 plus 0, and for the third one, we're going to get 1 plus 0, 2, 2, and 1. So the direction of greatest increase is going to be this, and that increase is going to be the magnitude of gradient of P, which is the square root of 4 plus 4 plus 1, which is going to be the square root of 9, which is going to be 3. Alright. The next problem involves implicit differentiation, which we did not cover and will not appear on the exam, so I will skip it. Although it isn't that hard to, well, let me actually go through it, but I'll do one of them, but I don't think that this will appear on the test like the other ones. I think this test was kind of taken from 230, but okay, let's see. So let x squared y plus y squared z plus z squared x equal 13. We want us to find partial of c with respect to x. Okay, so we can just put this in here, put it through, and so for the first one, we are going to get partial of z with respect to x of x squared times y, and that is going to give us just a normal 2xy. For the next part, we're going to get plus y squared, and then we would get partial of z with respect to x, like normal implicit differentiation, plus, and then we would have the product rule for the third one, so that would be 2z times the partial of z with respect to x times x plus z squared is equal to 0, which means that we have 2xy plus z squared is equal to negative y squared minus 2zx times partial of z with respect to x. This is this, and this is that. So now we can divide by the beginning part, and we will get partial of z with respect to x is equal to 2xy plus z squared over negative y squared minus 2zx. And in order to find what this is at the given points, we just need to plug them in. So I'll skip that, but that's how implicit differentiation would be done. Okay, let me see. No problem. Okay, so the next problem, they want us to again linearize this function of a point and use it to approximate another point. So let's do that. So the approximation of x, y is approximately f at 10 into 2000 plus partial with respect to x of x minus 2000 plus partial with respect to y of y minus 1, sorry, x minus 10, y minus 2000. Okay, So the partial, oh, I'm not actually here, is y over x cubed, and the point that we're trying to approximate is 10.23 and 2018. Okay. So partial of f with respect to x is y negative y times 3x squared over x to the sixth power. Okay, partial f with respect to y is going to be just 1 over x cubed. So I'm not going to plug in the numbers and see what happens, but you can do the same thing that we just did. Plug in all the numbers that we need to. This and this, we're going to here, 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 and here. And we would need to figure out what this is. And we would need to plug 10 into our x and 2000 into our y. Okay, so I'm going to leave the rest to you. Find the equation of the plane tangent to the surface at that point. So once again, this would be similar to the linearization problem, so I'm going to skip it. It also involves some implicit differentiation, just the way it's written. So once again, it's probably not a problem exactly like this one up here, but you will need to know how to find the equation of tangent planes, and it's very similar to what we just did. Okay, the plot below shows the level curves of some function. Use this plot to answer the following questions. So they say, which one of these points is a critical point of f? And the answer would be C. We clearly, E is on a counter line. If we go in one direction, we're going up, the other direction down. Same thing with A, but C is going to be the minimum of this function. At the point A, the sign of the partial with respect to x is, so if we move along A in the x direction slightly, we are going to be going down, so it's going to be negative. And okay, at the point B, the sign of y is, so now if we move along B and we move up in the direction of y, we are going to be going up, so the sign will be positive. Okay, at the point A, the sign of f of y is, so the point A, and if we move in the y direction, we're again going up, so the sign of y will be positive. Okay, next question. What type of surface is the graph f of xy is equal to x squared, 2x plus 3y? That's a plane. What type of curves does the tangent map of this consist of? It would be lines. What type of surface is the graph f of xy? Is x squared plus 2y squared. And that would be paraboid with something like this. What are the counter maps? They are going to be ellipses. Okay, so that's the end of this test. I'm going to post this now. If you have any questions about any of these questions or about the test in general, please let me know. Again, implicit differentiation will not appear, so don't worry too much about that. But the other things might appear. So if you have any questions about it, let me know. And